Alright, let's do this. Pretty unusual time for me to try to do one of these. I saw this earlier, thought about it, didn't really have an idea how to do it, so I have something now. I guess I'll try to do it before I go to sleep, but let's see. 1504, count submatrices with all ones. Given an m by n binary matrix mat, return the number of submatrices that have all ones. So this can be similar to the last one, but it can be any dimensions for the submatrix of ones rather than just a square submatrix of ones. So here there's 1, 2, 3, 4, 5, 6, 6 1 by ones, and then like if we do the 2 rows by 1 column, there's 1, 2, 3, and then if you do a 3 row 1 column, there's 4, and then if you do 1 row 2 columns, there's 5, 6, and then there's a 2 by 2, which is 7. So 6 plus 7 is 13, I think. Yep. And here there's 1, 2, 3, 4, 5, 6, 7, 8 1 by 1s. And then the 1 by 2 would be 1, 2, 3, 4, 5. 1 by 3 would be 6, 7. 2 by 1 would be 8, 9, 10, 11. 3 by 1 would be 12, 13. 2 by 2 would be 14, 15, and then there's 1, 3 by 2, so it would be 6. Missed some. 1, 2, 4, 2, 2 by 3. Alright, so anyways, it's 24. Okay, so from yesterday's deal, if you were to have kind of a counting of rectangles and then try to extend the sides of the rectangles that you counted, you might be able to count new rectangles. So what I'm thinking about here is treating each rectangle as counting it based on almost like treating each rectangle as the top left of the rectangle. So if I start here as the top left of the rectangle and try to count everything that has this as the top left square, it'll kind of extend this way and get these two, and extend this way, extend this way as well. So it'll kind of extend to the rows as far as right as possible where this is still the top left, extend down in the column. And for every rectangle that is created from that process, I need to treat it as a separate rectangle and see if it can extend. So if I start with just this rectangle, it's going to just extend. It's going to just try to extend to be a 1 by 2 and a 2 by 1. But if I start with a 1 by 2, it's going to try to extend to be a 1 by 3 or a 2 by 2. And then I'll just need to prevent it from doing the same. It can possibly reach the same rectangle in 2 different ways, and I just need to have some sort of set to check that it doesn't redo a rectangle. Okay, so what I need is first to create the consecutive from any position, the consecutive amounts next to it, above it, and to the right of it, like I had in the previous solution. So consecutive above from every position. Actually, let's start with the rows and columns. rows is the number of subarrays in the 2D matrix, and then the columns is always going to be the length of the first row. And then go ahead and initialize consecutive above. It's going to be 0 times the number of columns for every row. And I'll do that again for the consecutive to the right, or left, consecutive left. And just to be sure, I'll go ahead and print that they're the right size. Rows is the length of the matrix. Row is not defined. Whoops. Length of first row at index 0. So, okay, it's the right size. And because I want to possibly index from row 0 above it, then I need to have an extra row. So I think it's row plus 1. Same deal. If I have a column and I want index to the left of it, I might start with column 0, index column 1 left, so negative 1, so be wrapping around to the extra column there. So not go out of bounds on indexing. And then I need to have some sort of set that is sane to avoid some future duplication of iteration over the possibilities. Also to note here is that the size of the matrix is actually pretty small. I don't think this solution that I'm going to have is going to be anything less than n squared or n by n. It might be n by n times n by n. It might be quadratic with respect to the number of elements in the matrix itself. I don't think the solution I have in my head, I don't think is very fast. Or it's not like, it's like n squared, something like that. It's not n log n. Although I think maybe this efficient solution would be n log n here. Anyways, so first pass, I need to set up my consecutive above, consecutive left. So for every row in the range of, let's say, for every row index, whatever, in the range of rows, every column in the range of columns. Say the value is whatever is that spot in the matrix. Now if the value is 0, then it's not going to chain a consecutive. Otherwise, the consecutive above at this position is 1 more than the consecutive above at position above it. So the row minus 1 column. And the consecutive to the left of the row and column is equal to 1 more than consecutive to the left of the same row and column minus 1. Okay, let me go ahead and just verify that that is doing what I expect it to do. Okay, so for the first row, it's consecutive above, so these two elements inclusive of itself. So there's 1, 1 chained from that spot, and then there's 1, 1 chained from that spot. And then on row 2, it should be something like 2, 2, 1. So 1, 1, 2, 2, 1, and then 1, 3, 3. Or technically there's like 0, 2, 2, 1, and 1, 3, 3, 0. Yeah, so yeah, 1, 1, 0, 2, 2, 1, 1, 3, 3, 0. And this is just a dummy row to not go out of bounds. And then for the consecutive to the left, this is going to be 1, 2, 1, 2, 3, 1, 2, 3, or like 0, 1, 2, 0, 1, 2, 3, 1, 2, 3, 0. 0, 1, 2, 0, 1, 2, 3, 0, 1, 2, 3. Okay, so it's matching what I expect it to do. And then I also want to start off with every possible one in some sort of queue, processing queue. And then just process the queue. So I think the queue could be an array. Does it need to be a... Does it matter the order of which I process this? So it could be a stack, I guess. Okay, I think I can make a stack here. So the stack is going to contain kind of stack contains rectangles, or it's going to be tuples. This is the process stack here. Contains tuples of, how do I want to store it? I think it's going to be position of RC and the size of it. The size. RC. Yeah, maybe the size, which is the length and height. The row and column at the top left, and the length that matches with row. So if I have this, let's say this thing from here to here would be like row 0, column 1, and row 0, and the number of rows. Okay, so this would be height and width. Contains tuples, RC, that define the top left, RC, row and column of a valid submatrix of valid 1 submatrix. with height, and with the dimensions. So each time I have a valid submatrix, I'll see if I can't extend the sides of it based on information from the consecutive rows, consecutive above, consecutive left. Okay. So for every one that I see, it's going to create a starting spot for the stack. So stack append tuple, that is this row, this column, 1, 1 for the width and height. Okay, and then I can do while the stack is this. I also need to add this to the scene, because everything that is seen here should be added to the set. Set.append, no, set.add, no, scene.add this tuple, row column 1, 1. I wonder if I should just create a single tuple and add that, append that, add that here, but then create two tuples. I'll call this submat. It's going to be row column 1, 1. Stack.append the submat, and scene.add the submat. Okay, so while the stack exists, submat is going to be whatever's top of the stack. When I pop it out the top, then I should be able to increment the answer as well. Each thing causes one valid submatrix. And then I'm going to try to extend left and right. So I have a position here. Actually, so if I think about having, like, let's say I start with this as the row column, and I think I might need another buffer. I think I might need another buffer column to the left. Let's see. So consecutive left to, actually that's fine. The dummy works on this side as well. Okay. So if I have extend left, extend to the right. So let's say I have a 2 row 1 column starting from this one. So I would need to check this position to see if it has consecutive above. That's at least the number of rows here. So I need to find whatever this position is. So if the number of rows here if the number of rows this is not sitting, so let's go ahead and say this row, this column, the height and the width for this tuple. So the height of this thing, say it's 2, is less than or equal to the consecutive above at the correct position. So if this is at position row, it would be row plus the number of rows. Row 0 plus 2 plus this row. Must be the number of rows plus minus 1. So row plus height minus 1. And so it'd be row height here is 2. This thing's row 0. And row height minus. And then column should be the column plus the width minus 1. So it's 2 by 1. Or is it just plus the width? Yeah, it's actually plus width. So if this is column 1, I just want to be in column 2 at that point. Seems a little weird why this is subtracting 1 and this doesn't, but I think that's correct because this position is, if this is 0, 1, it's the position at the top left, and the row is 2, and the height is 2, and the width is 1. Then if I do this position plus 2 height, 1 width, it would end up being here. Yeah. Two height, 1 width. Be past it. Okay, yeah. So from here I need to go back a row. Okay, so if the height of this thing is less than or equal to the second above that position, then I can extend this this submatrix on the right side. So the tuple for that would be this position, well, the same row and column as the top left. Same row and column as the top left. And then it'll be the same height. And the column is going to be plus 1. And if I haven't seen that in before, then I can add it to the stack. Add, and then stack.append. So I'm going to process that. Then if this row, or if the width is less than or equal to, try and extend it to the bottom side. So consecutive left, Charlie should be row plus height, column plus width minus 1. Just using kind of the complementary logic there. Submatrix, row, column. So the height plus 1, column, same column. And if that submatrix is not in scene.add submatrix, stack.append submatrix. that's it. And should be initialized to 0. Turn the answer. Alright, hopefully this doesn't go infinite. Width is less than or equal to consecutive left. Index out of bounds. Really? Alright, let's see what we got here. Probably crashing on the very first one, but let's see it. So 2111. So it's processing the very final one, I think. Which makes sense. Okay, so at row 2, column 1, which is, yeah, this one. So it's going to try extend left and right. Or, yeah, right and down. So it can't go down. Consecutive left. Maybe I need a dummy on every side, to be honest. So let's try and go. Let's try and go down. Yeah. Okay, again, I need a dummy on every side. Of my consecutive above and consecutive left. Okay, so it's processing up to 1, 0. So 1, 0, 3 rows, 0 columns. 3 rows, 0 columns. Seems a little small for the number of columns. Oh shit. This should be width plus 1. This should be width. Okay. Misspelled width. Okay. Memory will not exceed. Oh, jeez. Sweet Jesus. Okay. Let me think. This is I generally don't see this error. 150. How can it? What is the upper limit of the number of tuples I'm dealing with here? Man, I'm assuming this is the maximum size. 150 by 150 probably, or something close to that. Maybe 100 by 100, and maybe the last test case is 150 by 50. Actually, let's go ahead and just out of curiosity, see what is the actual size here. I wonder what the last test case is, if that's where the biggest thing. Maybe there's like zeros and ones in it, rather than just all zeros, or all ones. Anyways, okay. I wonder. So I can't just consider every single possible tuple formed from the top left. How unfortunate. So let's go ahead and do one thing here. Okay, say, I wonder how big, if it's a matter of how many things are in my one, two, three, yeah, that's 128 million. And each individual one is actually a tuple. Okay, so and each tuple has 4 integers. I can see how I run out of memory, sure. Yep. Okay, 120. So I can't store every single rectangle as much as I'd like to. I guess. So I'm storing the tuples because I need to keep track of the things I've seen. If I extend a certain matrix in a certain direction, like I say, I have a 2 by 1 here, and I extend it to the right. I just don't want. I want to avoid duplicating the count of extending like a 1 by 2 here, extending it down. And if I could just avoid that duplication without having to resorting to a scene set that has every possible tuple, I think I avoid most of my memory usage. At least half it, because a stack is going to be temporarily containing that stuff, maybe. It's processing that stuff, it's popping stuff off the stuff. So I mean, the stack can grow. Excuse me. The stack can grow. But okay, so I have a cell here. I would have to extend it to the left here. I would have to extend it, or to the right here. I have to extend it downwards because there's no. It just doesn't work if I don't do that. But is that the only time I would need to extend downwards? I guess I only need to extend downwards if I can default to just extending rightwards all the time, but only extend downwards if my current rectangle is a one column rectangle. If it's one column, it has to try to extend downwards. But if it's more than one column, like it's two columns, then it doesn't need to extend downwards because it could rely on something that is two rows extending rightwards. Okay, well that's a trick I didn't think of. So I don't need a scene, I guess. So hopefully that it saves enough memory. So it does need to extend right. So here, try to extend this submatrix on the right side if there's enough consecutive ones on that side. And then only extend submatrix downwards if it's one column. Submatrix. This is to avoid duplication of the same submatrix later on. So I can say here if the width is 1, okay, if width equals 1 and there's a 1 below, and yeah, 1 below, I could technically try to look within the matrix itself, but then it's not the right sizing, so I'll just use consecutive left on the below position. So row plus height will be the same columns, column plus 1 minus 1, just column. Yeah. Don't need the same. I guess I can just do, yeah, I guess I can just I need this submat tuple for the row column. And create a variable because there's no scene to need to avoid duplication there. So sub row column height width plus 1. And here again, it's not gonna append row column height plus 1. The width is 1. I wonder if this still goes out of memory. That can go pretty large. I'm gonna exceeded, really. Let me delete this test case. Because the other test case work. Could they do time exceeded? Let me just try submit and see if it crashes at the same spot or if it crashes earlier or fails earlier. It's going to fail at this case for sure, but just want to test to see if this works for the other cases. Okay, yeah, it's the same case that fails at. So every row and column, that's fine. Oh, that should be quick enough. Some processing. Okay, I mean, I guess this is more submatrices than I thought. Initially, I thought there'd be like quadratic, so like n times n. I guess it's 150 times 150 squared. 150 times 150. And then that's squared, quadratic with that. Hmm. 500 million. Okay. Yeah. Unfortunate. If it's all ones, then yeah. So one extend, this one extend, then this one needs to extend as well. Yeah, I think traversing every single submatrix. Guess that's just too slow, it needs to be faster. So is there a way for you to traverse? The issue I see is like if you start the position and you try to go as far right as possible or as far down as possible, you might not capture everything. So if I go here, I go far right as possible. It means I kind of miss out on. Can't really go down here. I could go down here earlier. For every square, why is the second dimension so much harder than the first dimension? I guess you could imagine this extending out to like a XYZ 3D matrix. I'm trying to find the number of submatrices that are 3D, like height, width, depth, that are all ones. One dimension is pretty darn simple. 2 dimensions is, guess, shouldn't be quadratic. Probably. And it should be, I can't imagine being linear. but maybe it is linear with the number of elements. Proportional to the number of elements. One. Extend it down, you extend it to the right. But when you extend it to the right, you extend it down. At this point, extend. If you start here, you extend to the right 3, you extend down 2, then this chunk is hard to find. Oh. One. Extend it. Extend every square. Every one. Every matrix, submatrix. One by 2 by 1 here. Somehow you need to quickly say that there's at least not just quickly, it's like slightly. 2 by 1 here. Tell you can extend here. Then when you do this, you extend this. And somehow maybe try to skip this thing and this thing being there. It's the fact that you go over the same thing multiple times, kind of. It's like a layering of the knowledge. Like technically, if I know that there's somehow a 3 by 2 here, then the process of getting there and kind of redundantly calculating this thing, this thing, this thing, and I'm kind of redundantly coming across submatrices. Oh. So if I have a 3 by 2 here, from this one to this one, definitely has these 1 by 2s. So maybe I can not count those. Then if I don't count them, I still need to somehow think of this as the starting top left of submatrix here. So how would I count this thing? One, 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 one. And to the right. Oh boy. I really wish this was quadratic rather than not quadratic. If this seems as fast as I'm going to be able to extend to this type of logic. I guess I'm missing something, like if I extend here to here, extend here to here, extend 2 rows, 1 column, 3 rows, 1 column, 3 rows, 2 columns. Rows, 2 columns, then it doesn't extend here. Maybe there's a 1 here. So we would need to zero, 0. Wonder. Could I go by the zeros and assume that the count starts with it's probably not gonna work. Probably not gonna work. Like try to find a complementary count. I could, like in theory, if you have a number of rows and columns of all ones, every single element's ones, then you can mathematically calculate how many submatrices of ones that there are. It's just a maximum number. And then if you consider where the zeros are, and for every zero, count the number of submatrices that have that zero within them, then those would be eliminated. But then it's at least 1 0. Have multiple zeros within that submatrix and you can't duplicate the count there. Or duplicate the elimination count. It's probably the same difficulty, maybe. If you can solve this one, you can solve the first. By definition, I guess. Is it any easier? The number of submatrices that have 0. This 1 by 1, 1 by 2. Yeah, 1 by 2, 1 by 2. 2 by 1, 2 by 2. 2 by 2. 3 by 2. And then this one just goes up here, left here. This thing sees another 0, so it stops there. In theory, it should be this one as well. One of them needs to count. Oh. Alright, go to sleep.